Hey, you guys. Welcome back. Today we're going to go over the study guide for the Unit 1B test. So, looking through this, question number 1 says, write the factors for the following numbers. So, we're looking for the factors of 5. What that means is we're looking for any number that goes into 5. So, the numbers that go into 5, let's see, where's the pen? There we go. Click back on it real quick. There we go. The numbers that go into 5 are 1, because 1 is a factor for every number. I can actually go and list 1 for all these numbers. 1 goes into every single whole number. Okay? So we got 1 and we got 5. Every factor comes with a pair. That's because when we talk about factors, we're looking for numbers that go into something else. So we're looking for the numbers that go into 5 evenly. So whenever we have factors, we kind of have a factor pair. I can check that these are right because 1 times 5 gives me 5. That means this number goes into 5 and this number goes into 5. They both do. When I have the factor pair, I know I won't forget any that way. Let's look at the next one. Factors of 10, I got 1 and 10. Notice how I always write them in pairs. It makes it a little easier, that way I won't forget any of them, all right? And then I got 2 and 5. Oops, there we go. And there are no others. Those are the only factors of 10. Looking at 30, I got 1 and 30. It's an even number, so I know 2 is a factor, and 15. And let's see, 3 and 10. And let's see, 5 and 6. And I think that's everything. Notice how I do them in pairs. That way I don't forget any. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Let's look at the next one. Write 5 multiples for the following numbers. So factors are the small numbers that go into the number we're talking about. Multiples, it looks like that word multiply. That's when we're extending the number. We're getting larger. We're looking for whenever we multiply. So I'd think about 2 times 1 gives me 2. 2 times 2 gives me 4. 2 times 3 gives me 6. 8, 10, 12. I could list an unlimited amount if I wanted to. Over here, multiples of 4. Again, multiples multiply. 4, 8, 12, 16, 20. Let me fix that 2 right there a little better. It's a 2, 12. That's all right. Looking over here, the multiples of 5. We got 5, 10, 15, 20, 25. Looking over here for 9, I got 9, 18, 27, 36, 45. Notice how all of these start with the number that was given. The multiples of 9 start with the number 9. The multiples of 5 start with the number 5. The multiples of 4 start with 4, 2, and 2. That's because every time we think about multiples, we're thinking about multiplying. I could multiply all these numbers by 1, and that's why I start with the number itself. 2 times 1 is 2, 4 times 1 is 4, and so on. So the next thing, simplify the following fractions. Whenever we simplify, all we're really thinking about is this right here, the greatest common factor. If I have 2 and 12, the factors of 2 are, let's see, 1 and 2, that's it. Factors are those small numbers that go into a number. Just 1 and 2. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. Yep, those are all the factors. So the greatest common factor between these two is 2. So I find the GCF, I divide by 2 on the numerator and the denominator, and now I can simplify. 2 divided by 2 gives me 1. 12 divided by 2 gives me 6. And that's my simplified fraction right there. Look at the next one, 14 divided by 20. Now, I'm not going to go through and write every single factor for all these numbers because that would take forever. At this point, I'm probably pretty good at thinking about the GCF because I've had a lot of practice with this and we've practiced a lot in class. So 14 and 20, I know they're both even numbers. I know no matter what, if I have 2 even numbers, they always have a GCF of 2. No matter what, I can always do 2. It might take a couple steps to simplify it all the way down, but I can always do it if they're both even. 14 divided by 2 gives me 7. 20 divided by 2 gives me 10. And these two don't have a greatest common factor, so I'm done. Over here, negative 6 over 15. These have a greatest common factor of 3, I believe. Negative 6 divided by 3 is negative 3. 15 divided by 3 is 5. So that's the simplified version of that one. Notice how I keep the negative in the numerator. All right. Over here, 3 over negative 15. Well, they both have a greatest common factor of 3. I can divide them both by 3. 3 divided by 3 gives me 1. Negative 15 divided by 3 gives me negative 5. And you can keep the negative in the denominator where it began, or if you're like me, I always move the negative to the numerator. You can keep it either place, whatever your preference is. Just know that when I ever write a negative fraction, I always put it in the numerator. That's just kind of the habit I'm in. And when you keep these things consistent, you can kind of keep them right more often than not. All right? Consistency is really key. It helps you keep things straight. So the next one, negative 4 over negative 7. Now, there is no greatest common factor that I could divide these by to take that number smaller. I can't make the number smaller. 4 and 7, I know it has to stay 4 and 7. The reason I put this one on there are two negative sides here. This negative and this negative. It's one of those things where we have to remember that every fraction is really just a division problem. And whenever I divide a negative divided by another negative, I get a positive. So all I've done here is take out the negative signs and make these both positive. If you want to get really technical about it, whenever I have negative numbers, I could really think about the factors of those numbers, 4 and 7. Now, if there were no negatives involved, the only factors here would be 1 and 4 and 1 and 7. If the greatest common factor is 1, I can't simplify, and I'm not going to simplify. Technically speaking, the factors of negative 4 and negative 7 would be these right here. The only time I can't really simplify anything is if the number is 1. If that's their GCF, I can't simplify with that. If it's negative 1, however, technically, I can simplify that. I could divide them both by negative 1. Both by negative 1. Now look, negative 4 divided by negative 1 is positive 4. Negative 7 divided by negative 1 is positive 7. That's because any GCF other than positive 1, I can technically simplify by. Okay? But that's kind of confusing for some. So if you just want to remember that, if I have two negatives in a fraction, I have to get rid of both of them because a negative divided by a negative is just a positive. However, if I have one negative, I'm going to keep it and I can put it in the denominator, the fraction bar, or the numerator. Totally your call. Looking over here, negative 3 and 3/9. Now, the whole number of a mixed number is not going to simplify. Instead, looking at this fraction, I can simplify that piece. So, negative 3, I'll keep it the same. 3/9. There is a greatest common factor of 3. I can divide both of those by 3. And I get negative 3. I keep that whole number the exact same, didn't mess with it. Now, 3 divided by 3 gives me 1. 9 divided by 3 gives me 3. And that is my simplified version here, right there. Perfect. Let's scroll down and look at the next one. Oh, it's actually right here. No scrolling necessary. This one says convert the following into either a mixed number or an improper fraction. So mixed numbers are this one, and this one. These all have a whole number with them out in front as well as a fraction with it. So looking at this, whenever I convert a mixed number to an improper fraction, I kind of always see this little arrow. It kind of reminds me of the order to take. Whenever I do this, I multiply the denominator by the whole number. 6 times 3 gives me 18. I'm going to add the numerator. 18 plus 5 gives me 23. And I keep the denominator the same. So whether it's a mixed number or a whole number, whether it's a mixed number like this or an improper fraction like this, the denominator is always the same. Look, the 6's don't change. Let's look at the next one. So I have negative 2 and 6/7. So I'm going to first multiply the denominator by the whole number. 7 times 2. Now, technically, if you were trying to do 7 times negative 2, that's not going to work out for you. Okay? The only thing that negative is doing is reminding me that I better keep it in my improper fraction. Other than that, I'm going to kind of pretend it's not even there. All right? At least in terms of multiplying and adding. So I have 7 times 2 is 14. 14 plus 6 is 20. I still have my negative from the whole number. Notice how I move it from the whole number into the numerator now. Negative 20. I'm going to keep the denominator the same of 7. Looking over here, same thing. That little curve method. the denominator times the whole number. 3 times 7. I'm kind of ignoring that negative. I'm just going to make sure I keep it in my final answer as the improper fraction. 3 times 7 gives me 21. Plus 1 is 22 over 3. Notice how the denominators don't change. And I keep that negative that I took from the whole number and put it in the numerator. All right. Look at this one. This is an improper fraction. The numerator is larger than the denominator. Whenever I do this, you really get to use that knowledge that a fraction is just a division problem. So, looking at this, I know that 17 over 10 is really just like 17 divided by 10. So, I'm going to think, how many times could that 10 go into that 17? Well, it could go in there once without going over. So that's going to be my whole number. The remainder, after it goes in there once, if it goes in there once, that's 10. There's 7 left over to get to that 17. A remainder of 7. And then I keep the denominator the same. Notice how the denominators never change when I'm converting between mixed numbers and improper fractions. They're always the same. Looking over here, negative 21 over 9. I'm going to think, how many times does this denominator of 9 go into the numerator of 21? 9 into 21, let's see, it goes twice without going over. There's a remainder of 3 because 9 times 2 is 18. But there's 3 left over, and then I keep the denominator the same. And now this is just like the problem up here. I can actually simplify that 3/9. So now this could be 2 1/3. And this negative over here, it's so hard to keep track of them, I know. Believe me, I get it. This negative is just telling me I better keep it over here with my whole number right there. So when I turn this into a mixed number, I'm looking for negative 2 1/3 as my final answer. Looking at this one, I kind of covered it up a little bit, but not too bad. Negative 16 over 4, I'm going to think, how many times can that 4 go into that 16 without going over? Let's see, 4, 8, 12, 16. Oh, it goes in there 4 times. There's no remainder. So I'm not going to have a fraction over here. Instead, I'm just going to have my negative sign out with my whole number. And there's no fraction, so that's it. It just becomes a whole number now. Because again, every fraction is just a division problem. Negative 16 divided by positive 4. That's negative 4. Let's look at the next one. Which fractions below are equivalent to negative 8 over 15? Notice how the negative sign is right next to the fraction bar. I don't suggest you write it that way just because sometimes your handwriting might make it look like that's just a really long fraction bar. It might look connected, and then I won't be able to tell that you wrote a negative sign. And you might not even be able to tell that you wrote a negative sign. So just be careful. But like we said, you could see it one of 3 ways: in the fraction bar, in the numerator, or in the denominator. So if I'm going through this, I'm going to look and find which ones are equivalent, meaning which fractions are equal. So looking through some of these, I see some of these with 8 and 15. I'm going to go look at those first because I think those are probably just testing me on my negative sign skills. So there's 1 negative. I know I can put it in any of those 3 places. This one has 1 negative. It's in the numerator. Perfect. That's fine. That is equivalent. This one has 1 negative. Perfect. That's fine. That is also equivalent. This one has 2 negatives. Doesn't work. When there are 2 negatives, that's like a negative divided by negative would really give me a positive like this. So that doesn't work. This one over here, well, there's no negative. That doesn't work. Now looking at these, 4/5, if I was going to simplify 8/15 into 4/5, I would need to find a greatest common factor that I could use to divide both of these by. There is not a greatest common factor between 8 and 15 that I could use to divide them both by. Some kids, however, always make this mistake. They're like, well, I'll divide 8 by 2 and 15 by 3. It's close enough. If they did that, 8 divided by 2 is 4. 15 divided by 3 is 5. But look, the GCF they might have tried to use, it's different numbers. That doesn't work. So I got to have the same GCF. If they're not the same number, I can't simplify it. So 4/5 doesn't work in any of these. And that goes the same issue with 2 over 5. There's nothing that works there either. There's no same GCF that I could divide by to give me 2 over 5. Now, I have to post this in parts because I have a 15-minute limit, so this will just be part 1 of the study guide. I will pick up with part 2, and we'll go over the next section on the study guide. All right?